Hello everyone, I am Abhinav and welcome to the post-contest discussion of the Codechef Starters around 152 TLE elements. Okay, in the first problem, it's given that you are given an array A containing n integers. You can delete at most two of its elements. Find the minimum possible value of max of A minus min of A. Versions. Okay, so of size n, and then what we are given is you can perform two deletion operations. You can just delete any two of its element, and then you need to find after those deletion what is the minimum possible range that the array can have. You have to perform the deletions in such a way so that you minimize the range of the array. Range of the array is the maximum element in the array minus the minimum. Okay, so like if we look at the first test case, okay, so here n is given as 3 and we are given this array 2, 3, 1. So the range minimum. So 3 to 1. Like for this test case, you can just delete any two element. Let's say you deleted these two elements. What is left? You are left with a 1. Here the maximum in the element is 1, maximum is 1, and the minimum is also 1. So 1 minus 1 would be 0. Your range for this array after these deletion would become 0. And if you, let's suppose, deleted the second and third element, then your array would be just 2. Here again, maximum is 2, minimum is 2, your range is again 0. So like for this case where the array size is 3, you can just delete any two elements. And for any array of a single element, whatever that element is, its range would always be 0. But what if n is greater than 3? Like let's take the second test case or the third test case here when n was greater. Okay, now what would you do to reduce your range? Here there are 6 elements. Okay, so you need to delete the elements optimally in order to minimize your range. Currently, what is the range of this array? For this array, the maximum element is, I think, this 1005, and the minimum element is 11. So currently, its range is 1005 minus 11, which is 994. Okay, this is the range currently. Now you need to delete two elements from this array and reduce this range. Okay, so what elements would you delete? Like in this case, if you just delete this 1005 and let's say you deleted this 11. Okay, let's suppose you deleted the 11 and 1005. Then what is your range for this new array, which is having 64, 998, 843, and 945? For this, your maximum value is 998 and your minimum value is 64. So here your range would be uh, 934. Okay, this so you have basically reduced your range from 994 to 934. Maybe by some other deletion you could have reduced it further. So you need to just find those optimal deletions. What two elements would you delete so that your this final range is minimized? Okay, so what you would do? It's like a very simple. First thing that you would do is sort this array. Okay, if you sort this array, then you can just look at those elements in a more cleaner way so that you can decide what you need to do. So let's suppose we sort this array. Okay, it becomes 11, 64, 843, 945, 998, and 1005. Okay, this is the array we get after sorting. Now, once an array is sorted, what is the range of the array? The last element minus the first element. The maximum value is the last element, minimum is the first element. So this is your range. Now, how can you reduce this range? If you delete some element in the middle, would it affect the range in any way? Let's say you deleted this 64 and 843. Your range would still remain 1005 minus 11. So what's the best thing to do in order to reduce your range? Is delete elements from the ends. Either delete this smallest element or delete this largest element. Then only you can reduce the range. So let's suppose you deleted this element. Now after this deletion, your range is now this 1005 minus 64. Now if you delete this 64, your range would become 1005 minus 843. Or so this is one option, delete the first two elements. Or what you could have done is uh, you could have deleted one element from the start and one element from the end. So delete this and delete this. So then this would have been your range. Or what you could have done is for this array, just delete the last two elements. So like you can understand, it's very intuitive and simple to understand that there can be only three cases: either delete first two element, or delete last two element, or delete one element from the start and one element from the end. Now, among all these three cases, just find out which one is giving you the minimum range. That would be your minimum answer. So what we are doing is dividing this into three cases. Either delete the first two elements, or delete the last two elements, or delete first and last element. These can be the only three cases. Can you think of any other case that you would be better than any of these cases? Because you would either delete from the start or from the end. And if you're deleting, let's say you're deleting the first element, then you only have option you have is delete the second element or the last one. So after first, if you delete the second, it's the first case. After first, if you delete the last, it's this third case. And if you start deleting from the end, then either you would delete the last two or first and last. Okay, so I hope it's clear why only three cases would be there. Either first last, or first two, or last two. Okay, now if you delete the first two elements, your final range is the last element. If I'm taking a zero based indexing, my last element is a of n minus 1. Okay, the first two elements are deleted, so last element and the third element. So in a zero based indexing, my third element is a2. So this would be my range after deleting the first two elements. And what would be my range after deleting the last two elements? It would be a of n minus 3. This is my last third element. Okay, the last and the last second are deleted. So last third is now the new maximum minus a0, the first element. And if the first and last are deleted, so now the new last is the last second and the new first is the second element. So you just need to find the minimum value among these three values. So just find the minimum among these three values. That would be your answer. Okay, I hope the first problem is quite clear. So we can move to the code now. Okay, what I did, I just took the input. This is the input part. Then I sorted my array. After this, I just took minimum of those three cases. This is first case. This is second. And these are the three cases that we are taking: an minus 1 minus a2. This. So I'm just taking the minimum of all those three cases. Okay, and the minimum of those three cases would be my answer. I'm just printing my answer. I hope this problem is clear and there is no doubts in this. If there is any doubt, you can just ask.
Can you please tell how did you get on both all the three cases?
Like I told this array, what are your options in order to reduce your range? If you delete any element from the middle, that is not going to affect your range. It would still remain the maximum minus minimum. So deleting any elements from the middle does not mean anything. You are not benefiting from that. So the only things you would do is delete from the ends. So what you can do is, if you have an array, this is the first, second, third element. This is the last second. This is the last element. So what all cases, either for your first deletion, either you would delete the first element or the last element, then only you can reduce the range. So if you delete the first element, your new array, if you delete this first element, this is now the new first element. This is the new last element. So if initially you deleted the first element, then you only have two options for the second deletion: either delete this or delete this. So either you would delete the first two or the first and the last in this case. Or at the beginning, if you deleted the last element, instead of deleting the first element. If you deleted the last element, then your two options are either delete this or this. So again, the only thing is last two element or first and last. So from the first case, you got either first two or first and last. And from the next case, either last two or first and last. So if you combine both of them, first and last was the same. So there are only three cases. Like, did you get why I'm doing this? Because to reduce the range, you can only delete from the start and the end. If you're deleting from the middle, that is not going to reduce your range. Okay.
Yeah, got it.
Okay. So I think the first problem is clear to everyone. So we can move to the second problem. Okay, maximum Hamming distance. So you are given m strings, each of length n. The ith string is called Si. The strings contain only the characters 0, 1, or question mark. You must replace every question mark with either a 0 or a 1, and hence obtaining m binary strings. Okay, if you perform these replacements optimally, find the maximum possible sum of Hamming distances between each pair of strings, and the definition of Hamming distance is given. So basically what you need to do here is, okay, first let's read the definition of Hamming distance. Hamming distance between two strings is equal to the length, or two strings of equal length is the number of positions at which the corresponding characters are different. For example, between these two is, at the first position, this 1 and 0 are different. So 1. At the second position, 0 and 0 are same. So that won't be counted. This 0 and 1 are different. So plus 1. This 1 and 1 are same. So won't be counted. So there are two positions, this and this, where the two strings have different characters. So Hamming distance between these two binary strings is 2. Okay. Since they differ at the first and third characters. So this is the definition for Hamming distance between any two binary strings. Now we need to find is, you are given m strings. Okay, like here you can see, let's suppose you are given these three strings. Now you need to, there would be some question marks in the strings. Okay, you need to replace these question marks by either a 0 or a 1, such that after replacement, the final m strings that you get, those m binary strings, if you take the sum of Hamming distances between each pair of string. Okay, what does this sum means? It means just take any two pair of string, add their Hamming distance to your value. So the sum of the Hamming distances between every pair of string, that sum is the thing which you need to maximize. Okay, so that the sum of Hamming distance between any pair of string is the thing that you need to maximize. So accordingly, you have to replace those question marks. Okay, so like, let's take some test case to understand better. Okay. 2 2 question mark 1 0 question. Okay, let's say you have this test case. Okay, this is your first binary string, which is 0 question mark, and your second string is question mark 1. Okay, let's say you are given this. Okay, 2 is the number of strings and then m are given there. Okay, so you have m strings of length n. Now for these m strings, you need to replace these question marks by some value, either 0 or 1, so that after the replacement, whatever final m strings that you get, the uh, Hamming distances between, sum of Hamming distances between every pair is maximum. What does that mean? Let's say I replace this question marks. Okay, let's say I replace the first question mark by a 1 and second question mark by a 0. Let's say I replace it like this. Okay, now after this replacement, this is the final m strings that we get. This is my first string, this is my second string. Now I need to find for every pair. So for this string, it would pair, here you are given just two strings, so there would be only one pair. just a single pair between these two string. So what is the Hamming distance of these two string? They differ, they don't differ, they don't differ. So its Hamming distance is 0. So for this replacement, your final value is 0. Now let's say instead of this replacement, I replace the first question mark by a 0 and the second question mark by a 1. It's like this. Now what would my Hamming distance be? These are different, these are different. So there are two places where they differ. So Hamming distance would be 2 here. So this replacement is giving me a greater value. So whatever replacement gives me the maximum value, that's the value that I have to print as my answer. Okay, like let's say here there was one more string. So if there were 3 strings and let's say I did this replacement only. So here what would my Hamming distance be as the sum of Hamming distance? So first here there are 3 strings, 1, 2, 3. So I have to take the sum of distances between every pair of string. So 1, 2, if I take the first 2 strings, it's 1 plus 1, 2. Its Hamming distance is 2. For the pair 2, 3, if I take 2, 3 as the pair, this is different, this is different. So again 2. If I take the pair of 1, 3, then for the pair of 1, 3, this 0 and 0 are same, 0 and 0 are same. Its Hamming distance is 0. So the sum of Hamming distances between every pair is 4. So 4 would be my final answer if this 4 is the maximum that we can get by any kind of replacement. Okay, so I hope the problem is clear what you need to do. Now you just need to find how can you maximize this Hamming distance. So if you like look closely, let's say you have some binary strings. Okay. And then there are some question marks also. Okay, something you have. Okay, let's look at, let's index them 0, 1, 2, 3, 4, 5. Okay, so what you need to maximize is the sum of Hamming distances. Now, what is a Hamming distance? Is for the 0th index, whether they are different, if these two are different, that would add a plus 1 to my answer. If these two are different, that would add my a plus 1. If these two are different, a plus 1, plus 1, plus 1. And if these two were same, that won't add to my answer. So finally, what we need to compute? This, how many are different? How many are different in this? Then how many are different in this? Okay, so for every pair, we need to compute. So if you just look at this first index, so for all the string, if you just consider the 0th index, so you can just see that for every index, if you just consider, they all are independent with each other. Like if there is a 1 here and the 0 here, do these two depend on each other? For my final answer, I would compute among this row, in this first row, how many pairs are different. In this second row, how many pairs are different. In this third row, how many pairs are different. That's what we are computing. That's what my final sum is. So like we can compute for every like row or column, whatever. Let's say it's a row. Okay, so for every row, how many pairs are different? For the second row, how many pairs are different? So for every row, we can compute individually for every index. So they are not related to each other. That's the first observation that you can get. So how can you maximize the number of pairs that are different in a row? So first thing that I would do is for the first row, I would compute. Okay, let's say there are no question marks. Okay, let's say in my first row, I have 1, 1, and 0. Then how many pairs would be different? This one would be different with this 0, but not with this one. Okay, and this one would be different with this 0. So in this case, this and this, there are two pairs that are different. Let's say there are X number of ones, okay, and Y number of zeros. Then how many pairs would be different? A different means there is 1, 1 and a 0. Whenever you select a 1 and you select a 0, then you get a pair which are different. If you select both zeros, you won't get a different pair. If you select both ones, you won't get a different pair. So if in a row there are X number of ones, like here the value of, here for this there were two ones. So x was 2 and y was 1. Basically what I'm telling, x denotes the count of ones in this particular row. Y denotes the count of zeros in this particular row. So then I can say that my sum of Hamming distance for this particular row would be what? Just you would select a 1 and a 0. So there are x ways to select a 1 and y ways to select a 0. So sum of Hamming distances would be x into y. So like you can use some maths and get this, that if there are x number of ones and y number of zeros in a row, then the sum of Hamming distances, what is that? That is the number of pairs such that we get different values. That is going to be x into y. There are x ways to select a 1 and y ways to select a 0. So x into y would give us the number of pairs that are different. Okay. So for every row, so x, I'm saying that for the ith row, this x I would say is c1 for the okay, c1 is the number of ones in the ith row. Let's say c1i is the number of ones in the ith row, and c0i is the number of zeros in the ith row. Okay, so then I would say that for the ith row, c1i into c0i is going to be my sum of Hamming distance for the ith row, and this thing, if you for all the indexes, then this is the final value that we are actually obtaining. Okay, this is the final value that we are actually obtaining. Okay, this is the final value that we need to maximize. Okay, now here the thing is, if you are given just zeros and ones, you can just compute this value, that would be your answer. But here we are given some question marks as well. So you need to replace these question marks optimally in order to obtain, you need to replace this either by a 0 or by a 1 in order to maximize this value. Okay, so for a particular row, let's say the count of ones is c1i and the count of zeros is c0i, and the count of question marks, let's say c2i, represents the count of question marks. So these many values are there which can be replaced either to a 0, either to a 1. Okay, so what would you replace them with? Let's say this, there are 3 ones, 2 zeros and 2 question marks. Okay, so for the 2 question marks, either you can replace both of them by a 1 and 1. So your count of 1 would become 5 and count of zeros would remain 2. It would be 5 into 2, 10. Or if you replace one question mark with a 1 and another with a 0, your count of 1 and 0 would become 4 and 3. So 4 into 3 would be 12. Or if you replace both of them by a 0 and a 0, it would be 3 and 4. So 3 into 4, it would be 12 again. Which one is maximum? 12 is the maximum here, either this or that. Okay, so basically you have, if you look at it, you have 3 plus 2 plus 2, total 7 elements. Okay, among 7 elements, 5 elements are fixed and 2 elements is on you what you need to replace. So either it would be 3 into 2 plus 2. Okay, like for 7 elements, you are basically dividing these 7 elements into ones and zeros. This 5 plus 2, this would always be 7. So if your x plus y is some constant c and you need to maximize the value of x into y, so what you can do? So for 7, either you can have 1 into 7, or you can have 2 into 6, or you can have 3 into 5, or 4 into 3, sorry, 3 into 4. For 7, 1 into 6, 2 into, okay, so for 7 elements, it would be 1 into 6, 2 into 5. Let me write it. 1 into 6, or 2 into 5, or 3 into 4, or 4 into 3, or 5 into 2, or 6 into 1. Okay, so these are the only cases. Here it's 6, 10, 12, 12, 10, and 6. like from mathematics also you can understand, and just by looking also you can understand, the best you would get would be in the middle. Like if n is odd, it would be basically, if n is even, if n was 8, the best you would get would be n by 2 into n by 2. That's the best you can get. And if n is odd, it would be the seal of n by 2 multiplied by floor of n, either 3 into 4 or 4 into 4. So this middle value would be the greatest always. So you would always try, and it would always be increasing from 1 into 6 till here, it's increasing, and then here it is decreasing. So basically, what you would do is, if you have the number of ones are very large, let's say 10, and number of zeros are 2, and the number of question marks is 3. So in this case, you would try to uh, make them as close as possible in order to maximize. So you would add this 3 to this C0 and make it 5. So 5 into 10 would be more. Instead, if you added it to 13, then 13 into 2 was less. It was just 26. But if you add it here, then 10 into 5 is 50, which is much greater. So always you would add these question marks to the lower value. That's the first thing, until they both become equal. So basically you are trying to make both C1 and C0 to be as close as possible. The closer they are, the greater their product would be. Okay. So I hope that is clear. Now there can be two cases again. Okay, let's say this is one case where you are adding all the three question marks to 0. You are making it 5. Or if this zero, if this was, let's say 9, then what you would do, you would add a +1 here, they would become 10 10. You would still have 2 remaining, so you would give 1 1 to each. So basically you would have add a +2 and a +1 and make them 11 and 11. So that would be the best case here in this case. So first you would see the difference between the greater and the smaller value. If that difference is greater than this number of question marks, then add all the question marks to the lower value. If that difference is less, then add that much to the lower value to make them equal. After that, just distribute to both of them. Okay. So basically, you would have two cases. Is if C, uh, let's say with Mn, I'm denoting the minimum among C0 and C1, and Mx denotes the maximum among C0 and C1. So I would say if this maximum minus minimum, this much value you would add to your minimum at least. If this is greater than the number of question mark, then you would add all the values to the minimum. So your answer would be mx into mn plus c2. Okay. Or else what you would do, you can make both of them equal. So basically what, if both of them can be made equal, so basically they would either be equal or a difference of 1. So if the sum, with sum I am denoting as C1 plus C2 plus C of question mark. Okay, if this is the number of elements, that is going to be M or N, whatever, M. In this case, there are M strings. Okay, so it would be basically M by 2 into M by 2 for even case, and for odd case, floor of M by 2 into seal of M by 2. Okay, so I hope you understand. Either you can do this or just add like you added here. Okay. So basically when you can make them equal, so for even case, they would become equal M by 2, M by 2. For odd case, it would be just like, if this is 7, it would be 3. Okay, like that. So this is the case you can write. This you would do for every row basically. For every I, you would compute this thing and do this. So what overall complexity would be? So you would go to every row. So for every row, you would compute like the, just iterate here and just compute the number of zeros, number of ones, number of question mark. And then once you have computed these three variables, this is a O of 1 calculation thing. Okay, add that to your answer. For the second row, do the same. So basically you are moving to the whole matrix. So your overall complexity would be M into N. In O of M into M, you are just doing it. Okay, I hope the complexity is clear. So we'll look at the code and then understand. I hope the logic is clear. Now we can move to the code if the logic is clear. Okay, let's see the code, what I'm doing. Okay, one more thing, like in my question, I was given the constraints that sum of n into m would not exceed 3 into 10 to the power 5 for all test cases. So O of n into m complexity is acceptable. Okay. Now I'm taking this input. After that, I'm assigning my answer variable, answer equal to 0, initially 0. Now I would go to every row, basically for every I would compute this C0, C1, and C2. All these three values would be computed. So I would go on a loop. And if S of Ji is 1, C1 plus plus. If it is 0, C0 plus plus, else C2 plus plus. The count of zeros, ones, and question marks is computed here in this loop. Now I would just, one way is take the min and max, which I did here. Mn denotes the minimum of C0, C1, Mx denotes the maximum of C0, C1, and then my computation just required Mx and Mn. So, or another way to do that was, let's say I assume this C0 is less than C1. And if it is not, if C1 is less than C0, then just swap both of them, because it doesn't matter what it is, the count of 1 and 0. So just swap both of them so that C0 becomes always less than C1. So C0 would denote my minimum, C1 would denote my maximum. So that's what I'm doing in my code. If C1 is less than C0, if that condition is not satisfied, I would swap them so that always my C0 is less than C1. Now my C0 is minimum, C1 is maximum. So I'm checking if this max minus min is basically C1 minus C0, because C1 is storing the maximum, C0 is storing the minimum. If it was not the case, then we have swapped it. Okay, if it was opposite case. So you could have written this also, Mn equal to this thing, Mx equal to this thing, and used Mn and Mx in the if condition. Okay, that was also fine. And then I added max multiplied by min plus c. Okay, max multiplied by min plus c. That is added to my answer. In the else case, I took the sum. Actually, this was not required. Instead of sum, I could use m, because m would be the sum of the count would be m on this. So instead of sum, I can just use m here. Okay, this is not. So this is the flow division of m by 2 would that I'm adding to my answer. And this thing is so I hope the code is clear to you. Okay, what would be the time complexity if you look at the code? This input part is m times we are taking n size string. So this input part is O of m into n. Okay, and then here this loop is running m times. These are O of 1 operations times, and these are constant operations. So this whole thing is running n times. So overall, it's O of n into n. Okay, so finally my time complexity is going to be O of n into m plus n to m, so O of n into m. Okay, this is well accepted. I hope the second problem is clear to you. There's no doubt. If there is, you can ask.
Excuse me, sir.
Yeah.
Excuse me, sir.
Yeah.
Sir,
Tell.
when I was solving the problem, my approach was same. But in spite of like taking the values for C0, C1, and C2, I was storing it all in an array, like number of ones, number of question marks and all. But it was giving me TLE. Why so? Approach was same. Like there was nothing change in that.
Sorry, I think your was cut middle. What you will tell? Sorry, I can't
Sir,
hear you.
sir, I was saying that
Yeah.
when I was coding, my approach was same, but like you took the variables C0, C1, and C2. In spite of that, I pre-computed it, like number of zeros, a number of ones, a number of questions marks in a particular index. But it was giving me TLE. Why so?
Maybe somewhere maybe I would have to look at your code to know why. That is also okay if you are computing for every index, you are storing them in an array. Maybe in your implementation, you would have done somewhere some n square or m square loop. If you can send your code at the end, I can look at it.
Yes, sir. For every index, I was iterating through all the strings and like checking like what is the value present at a particular index for a particular string. So it was n into m, like it was going n into m complexity, but still.
Um, you send your code, I'll look at it at the end.
Okay, sir. Thank you, sir.
Okay, I think there's no more doubt to anybody else. We can move to the next question. Okay. Okay, the third problem is anti-palindrome queries. So here we are given an array B of length M is called an anti-palindrome if no pair of its opposite elements are equal. So this is the definition for an anti-palindrome, and that is like for a palindrome, all the opposite pairs should be equal. For an anti-palindrome, all of them should be unequal. That's what the anti-palindrome means. Okay. For example, 1 and 2 and this. So here 1 and 2 are unequal. So it's anti-palindrome. 1 and 2 unequal, 2 and 3 unequal. So anti-palindrome. Here 1 and 3 are unequal, but this 2 and 2 are equal. So it is not an anti-palindrome. Here this 1 and 1 is equal. So it is not an anti-palindrome. Okay. Now we say the array B is beautiful if every cyclic rotation of B is an anti-palindrome. So the definition for beautiful is given that if for every cyclic rotation of B, if the array is beautiful, then it is, if the array is anti-palindrome, then the array B is called beautiful. So cyclic rotation means if this is the array, you can rotate it by one cyclic shift. So this 3 would come ahead and all of this would be shifted. So this 1 to 2 is shifted right by one position and this 3 comes ahead. So this is one cyclic shift. Same way you can do. This is the second cyclic shift. So for all the cyclic shifts, if all of these array are anti-palindrome, then we would say that this is a beautiful. Okay. Now you are given an array A of length n, which contains only integers 1, 2, and 3. Answer Q queries on this array. Okay, you need to answer Q queries. For every query, you are given L and R, where basically you are taking the subarray from L to R. And for this subarray, if you consider this subarray from L to R as a new array B, you just need to find whether if you're allowed to rearrange all the elements of B, can you make this B beautiful after rearranging these all the elements of B, where B is the subarray from L to R. So for every query, you need to answer this in yes or no. And this is what you need to do. Okay. So N and Q are up to 2 into 10 to the power 5. So the size of the array can be up to 2e5 and number of queries are also 2e5. So if for every query you are doing some O of N operation, then N into Q would not be accepted. I hope you understand that. So you need to optimize this a little. And sum of N and sum of Q are also 2e5. So okay, so let's look at the first test case. Okay, this is N, this is Q. So this is the array that we are given, which is 2, 2, 3, 1, 3. Now you have these Q queries. Okay. So in the first query, let's say this is your array 2, 2, 3, 1, and 3. Okay, I'm indexing it. This L and R are given based on one based indexing. So let's say I'm indexing one based indexing only. Okay, now take the subarray from 2 to 5. Okay, so take this subarray. Now for this array, if you rearrange if you are allowed to rearrange the elements, can you make this array beautiful? Can you find any rearrangement of this subarray so that this is beautiful? Now, so your B is here 2, 3, 1, 3. This subarray. Okay. So can you make this be beautiful by any rearrangement? So if you look at this array only, this is beautiful as given in the question. Like, what's the definition of beautiful? It means for all the cyclic shifts of the array, it should be anti-palindrome. So for this, what all cyclic shift would be? One is this same array. This is one of the, okay, then you cyclic shift it. So 2, 3, 1, and this 3 would go ahead here. So this is one of the cyclic shift. Then again cyclic shift it. So this 3, 2, 3, and 1 would come ahead. Again cyclic shift it. So this 3 would come ahead and 1, 3, 2. Okay, if you again cyclic shift it would again become this. Okay, so these 4 cyclic shifts would exist. Now check whether they are anti-palindrome. So these 2 are unequal, these 2 are unequal. It is anti-palindrome. Unequal, unequal, anti-palindrome. Unequal, unequal, anti-palindrome. Unequal, unequal, anti-palindrome. So we conclude all of them are anti-palindrome. So we can say that this sub-array B is beautiful. So we would answer a yes here. Not for this. Here we would answer a yes. Same now, if you look from 2 to 4. Okay, if you look at this sub-array from 2 to 4. So this is basically, here your B from 2 to 4 is 2, 3, 1. This is your array. Now check whether for any cyclic shift you can make it beautiful. So if you like look at the problem statement only, you would understand that for anti-palindrome, if the array is odd sized, that's the first observation that I think while reading only you would have got that if the array is odd sized, definitely it is not going to be anti-palindrome. It can never be anti-palindrome because for the middle element, you are comparing the same element with itself, so it would be equal. So for an odd sized array, it would always be non-anti-palindrome. You can never make it anti-palindrome. So whatever cyclic shift whatever you do, it would never be anti-palindrome. So for this case, your answer would always be no. So for an odd sized array, your answer is going to always be no. That's the first, I think, the observation you can easily get. Now, again, for 1 to 2, it was 2, 2. Now, for this array, like you cannot do any rearrangement, it would remain 2, 2, and this 2, 2 is not beautiful because this 2 and 2 equal. So by any arrangement, you can never make it beautiful. So its answer is also no. So likewise, you need to complete. Okay, I hope the problem is clear. Now, what can you do here? Okay, the first observation we made, that is fine. Okay, so if what is the size of the subarray is R minus L plus 1 is the size of the subarray. If this is odd, we would always answer no. Okay, so that's the first thing you can get. Okay, if this thing is odd, always answer no. Now, when this is even, that's the case that we need to analyze. So before like finding out how you can like what all arrangement you can do, one more thing you can see in the question. It was given that values in the array are either 2 or 3, only 1 and 2 and 3. AI is only from 1 to 3. Okay, so the values are limited. There can only be 1, 2, and 3 in your array. So for any subarray, if you are given an array, let's say, if you are given an array, okay, if you take any subarray from L to R, let's say this, and then for this subarray, you are told you can do any rearrangement of this and then compute whether any rearrangement can be made a beautiful array or not. So what information do we need for this subarray? If we are allowed to rearrange the elements, then we only need the information of the values elements that it has. And we know that elements can either be 1, 2, or 3 only. So basically, if we know the count of ones in this range from L to R, if we know the count of ones and the count of twos and the count of threes, that's the sufficient information to uh, just differentiate an array from another array. So basically, if you get C1 as number of ones, C2 as number of twos, and C3 as number of threes, because whatever their order be, that does not matter because you can rearrange that order. So basically only the count of elements, what all things it contains, the things that it contains can be denoted just using three variables, C1, C2, C3, where C1 denotes the number of ones, number of twos, and number of threes. So if you can get these three values, now these three values can independently be used to answer whether that can be made a beautiful array or not. So these C1, C2, and C3, this, if you get this three value, this is sufficient to answer yes or no. Now we would see how can we answer yes or no based on this information. But first, in order to compute these three values, what you can do, one way is for every query, just traverse from L to R and count number of ones and zeros. But if you're traversing from L to R for every query, that would take O of n for every query, and n into 2 is not accepted, as you know. So an efficient way to do this is, obviously, you can guess, prefix sum. So you can pre-compute the prefix sum of this array. You would compute three prefix sums, one for the count of ones, one for the count of twos, one for the count of threes. So basically you will compute prefix one, that would denote the number of ones from 0 up till I, a prefix 2, prefix 3. You would compute these three prefix arrays. Using that, you can just say the prefix 1 of R minus prefix 1 of L minus 1. So in this range, if you subtract this, you would get the count of ones. Same way for 2 and 3. So these three counts can be computed in O of 1 if you pre-compute these three prefix array. Okay, so that's the first thing. Now, once you have got these three counts, you know that for this particular subarray, how many number of ones you have, number of twos you have, number of threes. Now, how can you compute if you have C1 number of ones, C2 number of twos, and C3 number of threes, then whether that array can be made beautiful or not. So to calculate that, let's see when an array is beautiful. Okay, let's dive deeper into that. When can you say that an array is beautiful? Okay, let's say an array is A0, A1, A2, A3. Okay, let's say for 4 elements only. What's the condition for it to be beautiful? So if I'm checking whether this array is beautiful or not, first condition is these two should be unequal, these two should be unequal. Okay, so A0 should not be equal to A3, A1 should not be equal to A2. Okay, and then I would cyclic shift it. So after cyclic shifting, it would become A3, A0, A1, A2. Okay, now my comparisons would be these two and these two. So basically A3 should not be equal to A2 and A0 should not be equal to A1. Now again, I would cyclic shift it. So A2, A3, A0, A1. Okay, so these two and these two. So A2 not equal to A1 and A3 not equal to A0. So like one more cyclic shift when you do, so A1 is 0, A2, A3. So I think that is already covered. A1 is 0, A1 is 0, A2, A3 is already done. So these 6 conditions we get for an array of size 4. So like if you look at these conditions, so what some observation can you draw? Like A0 should not be equal to A3. Okay. A3 should not be equal to A2. Okay. And A2 should not be equal to A1. Okay. A0 not equal to A3. A1 not equal to A2. Let's look at just A0. It should not be equal to A3. It should not be equal to A1. Okay, but there is no condition for it to be not equal to A2. It can be equal to A2. For A0, my conditions are with should not be equal to A1 and A3. Now for A1, my conditions are with A2 and again, this is A2 only and A0. So for A1, my conditions are with A0 and A2 only. For A2, my conditions are with A1 and A3, not with A0. So for A2, A1 and A3. Okay, this is already written here. Now for A3, it's A2 and A0 only. You can see for A3, it's A2 and A0. Okay, so what all things can be equal is A0 can be equal to A2 here and A1 can be equal to A3. These are the things allowed here. Okay, now if you further analyze it, this was for a size of 4. You can try out some for size of 5, for 6, 8 and all. For odd, obviously you would answer no. For even indexes, 6, 8 and all. Then by observing, you would get this thing is for any element A0, what all comparisons it is making. Initially, it is getting compared to the last element. Then after the next cyclic shift, okay, what all comparisons are being made. So if you consider this array like a cyclic array, so I would say that A0, A1, A2, A3, after that again A0, A1, A2. If you consider it like that, if you consider it cyclic, okay, this and then again this. If you consider a cyclic array, then comparisons are being made for palindrome condition between these two at a distance of 3, between these two at a distance of 1. Like if you take any other array also, let's say it has 6 elements. Okay, distance of 5, distance of 3, distance of 1. So all the comparisons are always made at odd distance. We are considering only even sized arrays, not odd sized arrays. So for even sized arrays, all comparisons are with odd difference. Okay, basically, if you just look at this, these two are being compared, they are at an odd distance. These two are compared, odd distance, odd distance. So basically, always two elements of different parity are compared. What does odd difference means? It means one of them would be at an even index, one of them would be at an odd index. If you look at this, there are no two elements. This is even, this is odd. Odd, even, odd, even, odd, even, odd, odd, even. Okay. So all the comparisons are between an even and an odd. So basically, it just means that for an array of size n, there would be n by 2 odd indexes, n by 2 even indexes. So all the among even indexes, they can be equal with each other. So here, if you see, like if you have A0, A1 up till A6, then just group them into two parts, odd indexes in one part. So A0, A2, A4, and A1, A3, A5. So the conditions are that any element of this group should not be equal to any element of this group. That's what the condition is. In this group, there can be elements which are equal to each other. But between these two groups, if you select any two elements, one element from this and one element from this, they both should be unequal. They both should be unequal if you select one element from this, one element from this. That's the condition basically for the array to be beautiful. Okay, so how can you check this? So now I know that I only have 1, 2, and 3 as my options. So when can I form a beautiful array? Either, so inside the odd indexes, I can just make it all threes, and in even indexes, I make it all threes, let's say, and in odd indexes, some 2 and some 1. That's one case. So whenever we compare both of them, they are unequal. So, but if you take a 3 and put it in some even index as well as in some odd index, that you cannot do. So all the three values, either all of the twos would be at even index or all of the twos would be at odd index. You cannot have one of the two at an even indexes and one of the two at an odd index. So basically you need to group these three values in two parts, either on assign them either odd index or even index or odd index. So that way. Now, after grouping them, what's the condition that they should fulfill is number of values in odd even indexes should be equal to number of values in odd indexes. You would always have n by 2 even indexes and n by 2 odd indexes. So basically, you have these three. C1 is the count of ones, C2 is the count of two, C3 is the count of threes. So if you just look among them, they should be divided in two parts such that for one part, the sum and the sum of the other part, they are equal. So either you can have this C3 equal to C1 plus C2, then you can do this, put these two in odd and this in even, then you can do, or maybe you can have C1 equal to C2 plus C3 or C2 equal to C1 plus C3. If any of these are satisfied, you say that yes, this array can be made beautiful by any of the rearrangement. So if any of these three conditions are satisfied, you would say a yes, otherwise you would say a no. I hope this logic is clear to you why I'm doing this. So basically first I would compute a prefix sum, three prefix arrays. One would store the count of ones, one of the prefix array would store the count of twos, one of them would store the count of threes. Now for every query, I would just calculate the count C1, C2, and C3 using these prefix arrays. In O of 1, I can compute these three values. Once I have computed C1, C2, and C3, then I would just check if any of these three conditions are satisfied. I would answer yes, otherwise I would answer no. That's the whole thing that we are doing. I hope the logic is clear. If there is any doubt, you can ask, then we'll move to the code. Okay, let's move to the code. So this is the input part. Then I'm instead of storing three prefix arrays, I'm using a 2D prefix array. So basically a 4 cross. So prefix of 0 does not denote anything, but this prefix of 1 stores the my prefix array for count of 1 and prefix of 2, prefix of 3. So these are the three. You can assume these three as three different prefix arrays, one storing the counts of 1, one storing the counts of 2s, and one storing the count of 3s. Now what I'm doing is for every prefix array, I'm assigning the previous value, prefix of ji as prefix of ji minus 1, and then I'm updating the current value as if a of, so I'm storing 1 base, my prefix array is 1 based, and my actual array is 0 based. So what I'm using a of I minus 1 because this 1 base I'm traversing, this I is a 1 based index from 1 to n. So a of I minus 1 is the 0 based index. So this, if this value is 1, I would update prefix 1 of I as plus plus. If this value is 2, my prefix 2 of I would be done plus plus. If it is 3, my prefix of 3 would be updated. So either of these three would be updated according to the value of A as plus plus. So I hope this prefix computation is okay. Like you can take three different prefix arrays and do a if else and compute it. There was no problem. I just did it in a single way. Okay. Now, once I've computed these three prefix arrays, this is vector of int. If it is not clear to you what I have written here, it is vector of int. Okay, and this is vector of int. Okay, and this is a loop from 1 up to less than n plus 1. So it is a loop from 1 to equal to n. Okay, this rep is a loop from 1 to equal to n. And this is a loop from 1 to 3. Okay, less than 4 is 3. Now, I'm going to every query. For every query, I get a L and R. This L and R are 1 based. First, I would check the size of this subarray, R minus L plus 1. If this is odd, I would just print a no. S, Y, and 0 is simply C out and no. Okay, so if this is odd, I would simply print a no and continue to my next query. Otherwise, this is vector int. Otherwise, what I would do, I would compute my C1, C2, and C3 using my prefix array. So this C again, I've taken a 4-sized array so that I can use my C1, C2, and C3. So these would be 3 different values that I'm going to use. And I would say that Cj is prefix Jr minus prefix Jl minus. This way I'm computing C1, C2, and C3. I've computed all the 3 of them. Now I would just print if the maximum, so this is a if condition, if the maximum of this thing, then see. Okay, I hope you understand what. Okay, so this was my condition. Okay, sorry, I'm taking the maximum, so I'll explain you what I'm doing that. So you can either write this equal to this, or this equal to this, or this equal to this. That would also be fine. Writing in the if condition. What I'm doing is combining these 3 conditions into a single one. Is if you have C3 equal to C1 plus C2, that means C3 is the maximum among these 3 values, because the sum of C1, C2 would always be greater than C1 and C2, or C1 is the maximum or C2 is the maximum. Basically what I'm saying that if the maximum among C1, C2, and C3 is to the left hand side, then the total sum minus that, it should be equal to that. So this maximum should be half of the sum. So this condition can be rewritten as maximum among C1, C2, and C3. If this is to the left hand side and they are equal to this, and we know the sum of C1, C2, and C3, the total count is n. So if this is equal to n by 2, then that is the same as writing this thing. Okay, so I have reduced that condition to max of C1, C2, C3 is equal to the length of the range by 2, not n by 2, the length of the subarray by 2. Okay, so if this is satisfied, I would write a cout yes, otherwise yeah. So I hope this code and problem, everything is clear. If you look at the time complexity, this input is O of n. Then this prefix computation is n times, it's n into 4 actually. So O of n into 4, writing n into 4 is same as writing O of n. So we can ignore the constant. This pre-computation is O of n. Now for every query, this computation is O of 4. So 4 times is same as constant, and this is an if else condition. So this whole is equivalent to a constant operation. So this is overall O of q. So basically my final time complexity, I can say that the final time complexity is, initially I'm writing an O of n here and O of q. So it is n plus q. Okay, so this would, O of n plus q would be well accepted. I hope this problem is clear so that we can move to the next problem. If there is any doubt, you can ask. Okay. Okay, let's move to the next problem, which is the easy version. So we'll look at the easy version first, then the hard version. Hard version is only a slight variation of that, and only one extra case that we need to handle. So if you're directly looking at the hard version, I would explain the easy version first and then just the change that you need to do to the hard version. So also watch the easy version to understand that. Okay, so let's look at the easy version first. So here you are given a permutation P of integers from 1 to 2n, which sum of element missing represented by zeros. Find the number of ways of filling in the zeros to obtain a valid permutation such that the quantity this is maximized. So basically you are given a permutation of 2n integers from 1 to 2n. So an even permutation were given of 2n integers. For that, some of the integers are 0, and you need to find the number of ways of filling in those zeros to obtain a valid permutation. So some of the values in that permutation are missing, which are represented by 0, and you need to fill up those missing values so that in your final permutation of 2n integers that you get after filling up those missing values, this thing is maximized. What is that? The absolute difference between first two element, absolute difference between next two element, and likewise up to the end. So you have just basically divided this permutation into pairs of two elements and just summing up the absolute differences between those pairs, and that thing you need to maximize. And also in the easier version, you are given that all the values in the even indexes are always 0 because that is they are unknown. Okay, so this is given in the easier version. Note that elements at odd positions may or may not be 0. Answer can be large, so find it. You need to find the number of ways of filling. Okay, sorry, you don't need to. You need to maximize it. You need to maximize it, and for the maximum value, there can be many ways of filling in so that the value is maximized. So you need to find the number of ways of filling in the zeros so that this value is maximized. Okay, that's the problem. And you need to answer it modulo this because the answer can be very large. Okay, I hope the problem is clear. So let's look at the first test case to understand more clearly. Okay, here we are given n equal to 3. It means we are given an permutation of size 2 into 3, which is 6. Okay, a 6 size permutation is given to us. Okay, let's look at this permutation. It's 4 0 1 0 2 0. So if I do a one based indexing here, okay, it is given in the easier version. All the even indexes are always 0. They are unknown. Now the odd indexes can be unknown or can be known. So here they are all unknown, 4 1 2. Now you need to replace these even indexes by some values in order to maximize that thing. So like one of the example for this would be, let's say you replace this 0. Let's here you need to have, for a permutation, you need to have all the values from 1 to 2n. So 1 2 3 4 5 6, all of them should exist. Here 4 1 and 2 are already there. So 4 2 and 1 are already there. This 3 5 and 6 are not present. So we need to replace these zeros by 3 5 and 6. Let's say I replace it, the first 0 by 3, the next 0 by 6, the next 0 by 5. Let's suppose I do it like this. Then what's the value that I would get is absolute difference between these two is 1. Absolute difference between these two is 5. Absolute difference between these two is 3. The sum of them is 9. So you can replace these three values by these three values in many ways. Among all the ways, you need to find the maximum value that you get and the number of ways to get that maximum value basically. So here, if you look like in the test case, all of the ways were explained, all of the replacements were explained. Among them, in two of the the maximum value was 9. And in these two replacements, there were two ways to get a value 9 by replacing. So there were two permutations where you were getting a value 9. So your final answer for this was 2. Okay, I hope you understood. Like here, the replacements were what are replacements? 3 and then 5 and then 6. Here 3 5 6 was the replacement, then you got a 9. Here 3 6 5 was the replacement, you got a 9. Here 5 3 and 6 was the replacement, you got a 7. And same for these, you got 7 7 7. The maximum among them was 9, and there were two ways where you were getting 9. So your answer was 2. Okay, I hope the problem statement is clear. Now how can we solve this? Okay, in order to solve this, first let's see some observations. So like after reading this problem, what did you get? The first bifurcation, the first observation, that while reading only, I told that what you are doing is actually you are dividing this array into, you are dividing this permutation into pairs of 2's. Okay, so basically you have all these values from 1 to 6, and you are just selecting two elements, placing them, selecting two elements, placing them. Likewise, you are just dividing in pairs of two, and for every pair you are taking the absolute difference and summing them. Okay, that's what you are doing. Now here in the easier version, it has made your job a little easy by telling you that all these even indexes are 0. So for every pair, one of the value would be fixed or even that is unfixed, and you would get one value where you can replace it by your value of your choice. So for an ideal case, let's say if all the values were 0, it's everything upon you to replace. Okay, let's say for n equal to 2, you are given this test case. You can just replace any value by yourself. What's the maximum you would, what's the maximum value you would obtain in this case? So you have 1, 2, 3, 4. These are the values that you are going to replace uh, in these. And then you need to make sure that the difference between first two plus the difference between next two is maximized. So what you would do? So if you replace them, let's say you replace them 1, 2, 3, 4. Okay, what's your difference? It's 2 minus 1. Okay, it's 2 minus 1 here and 4 minus 3 here. So you can basically look at it. This 1 is getting a minus sign, 3 is getting a minus sign, 2 is getting a plus sign, and 4 is getting a plus sign. That's what it is getting actually. So basically, whenever you are taking a absolute difference between two values, when you open the difference, it's actually the greater value would get a plus sign, smaller value would get a minus. Okay. Again, for this also, the greater value would get a plus sign, smaller value would get a minus sign. So basically, there for an array of size n by 2 elements would get a minus sign and n by 2 elements would get a plus sign. Okay. So you can rearrange them in any way. Now, what is the maximum value you would get? What is the maximum sum you can get if you assign n by 2 elements minus sign, n by 2 elements plus? Okay. So for this case, the best thing that you can do is assign the greater values as plus sign and smaller values as minus sign in order to increase your final overall sum. So what you would do, you would just divide this. You have 2n elements. So the first n elements would be assigned minus sign. The last n elements would be assigned plus sign. How can you do that? So in every pair, keep one element from this range and one element from this. So greater one would get minus plus and smaller one would get plus. So here you are not doing that. You are keeping 1 and 2 together. So 2 is getting a plus and 1 is getting a minus. And this is together. So 3 is getting a minus. So by doing this, the overall sum you are getting is 1 plus 1, which is 2. But you are getting 2. But had you done it like this, so how can you do it like this? Is just take one element from here, take a 4 and take a 1. Keep them together. Then take a 3 and take a 2. Keep them together. This way you would get 3 plus 1, which is 4, which is greater than 2. So the maximum value you get is sum of this minus sum of this. Sum of first n, sum of n plus 1 to 2n, this sum minus sum of the first elements. This is the final maximum value you are going to get. If you are allowed to just do anything. Okay. Now here in this question, what it's told is, okay, this is the value you would get if all of them are 0. Now what if it's this case, where in every pair you are definitely getting 1 0 in every pair. So one freedom is always there, but one of the value can be pre-assigned. So if this pre-assigned value is 4, so you can see if for 6 values from 1, 2, 3, 4, 5, 6, you can again divide them, that the first 3 should get minus sign, the last 3 should get plus sign. Now, can you always make sure in this case also? So if you have a 4, what you do, this is from the plus sign range, so it should get a partner of a minus sign range. So now for every element, you know that at least one of them is missing. So if one of the element is greater than n, replace it by an element which is less than. So this 3 was less than n, you replace it by that. Now, if this 1 was less than n, replace it with someone in this range. to make sure that there is one element in this range and one element in this range. So every element in this range would get a plus, every element in this range would get a minus. So for a 1, you replace it with a 6. For a 2, it was in this range, you replace it with something in this range, which was 5. So this way, you were able to maximize your answer. So for the easier version, when always there is one missing number, you can always do this. So always your maximum value is going to be the sum of elements from n plus 1, n plus 2, this up to 2n minus the sum from up to n. Okay, like you can compute that value. That is not required. What is required is number of ways to do that. That's the answer you need to print. Is this is the maximum value you are going to get. Not to, in order to get this value, what are the number of ways in which you can get this value? So for this case, if you look, like here you are replacing with a 3, with 4, you are replacing with a 3. You had an option of like 4, 1 and 2 are already done. 4, 1 and 2 are already done. You cannot use those. But what are the things that you can use? Is 3, 5, 6. So along with this 4, there is a 0. You need something from this range. Only option was 3. So you had to have a 3 here. There was no other option. Now with this 1, you need to have something from this range. So you can have a 6 here or a 5 also here. With this 2, you needed to have something from this range. So here you can have a 5 or a 6. So basically you had two options. Either this array replaced with 3, 6, 5, or this 5 and 6 can be interchanged also. There was no problem. It would still remain. So there was 2 ways. So what you can tell about the overall number of ways in a general case is, if you are saying that like you have divided the n numbers into 2 parts. One is the first n numbers from 1 to n. This is one part. And n plus 1 to 2n. This is another part. Okay. You have divided their numbers into 2 parts. Now just look at for every pair, the given values. The given values, you just cut them up. Okay, because they cannot be reused, like the given values 1, 2, and 4. They cannot be reused. What you are left with? In this left range, you are left with a 3. Right range, you are left with 5 and 6. So there would be 2 places. There would be one place where 3 is needed, and there would be 2 places where a greater range is needed. So here you can say that only one place. So here, if there are 2 places, you can say how many arrangements of 5 and 6. You can have anything at any place. So you can say that factorial 2 arrangements would be there, which is 2. If there were 3 values, you would say factorial 3 arrangements of them would be there. So basically, you can say, if after removing some values, if there are C1 number of elements remaining in the left range and C2 number of elements remaining in the right range, you can say factorial C1 into factorial C2. Answer, you can say, you can just rearrange them in any order, Basically, the places where you need to have a element from this range, the positions where you need to have an element from this range. So fixed, but which element should be at this range, that can be rearranged. So these C1 elements can be rearranged with each other. These C2 elements can be rearranged with each other. But this is the case where for every odd index, the value is null. So you are given for every even index, the value is 0. But for every odd index, AI can be 0 or AI can not be 0. It can be anything. But if I'm saying that for odd index, all the values are known, and even index, all the values are unknown, then you can just write your answer as this: number of unknown values in this range that you can directly compute by subtracting the known values in this range, iterating through the array. Number of unknown values in this range, which is C2, and you can just directly compute your answer as this. For the case where all the even indexes are unknown and all the odd indexes are known. Now, here in the easier version, this is given, but this is not given. Now, when some odd index is also unknown, so Like if you look at this second test case, here this for these two values, this was known unknown, but here both of them were unknown. Here known unknown, known unknown. Now so this is an extra case where both of the values are unknown. So like for 4, the available values are 1 2 3 4 in the left side and 5 6 7 8 in the right side. Here 3 5 8 are used. Okay, 3 5 8 are used. So you have 3 values in the left range, 2 values in the right range that are unknown. So what you can do is 1 2 3 here, along with 3 there is something in the right range is needed. Okay, now along with 5 there is something in the left range is needed. Along with 8 something in the left range is needed. But for these two values you can have a right and left or a left and right, both are acceptable. Okay, so basically what you would do, there are 1 2 and one of them, 3 places where left is needed, so 3 unknown. So C1 is 3 here still because there are 3 which are left, and C2 is 2 here because 2 are left. So the right range is 1 here and one of them. Left, some element from the left is needed, 2 here and 1. Okay, so 3 elements from the left range is needed, 2 elements from the right range is needed. So you can rearrange this as factorial 3 into factorial 2. But after rearranging, let's say I'm assigning this RL, that's one way, and assigning this LR is also another way. So you would multiply this by 2 to get your final answer. Once you keep it RL, so that rearrangement would be factorial 3 into factorial 2. Once you keep LR, that would again be factorial 3 into factorial 2. So into 2 will give you the answer. Let's say there is another 0 0. Then for this also you would have to do into 2. So basically you have to do 2 to the power number of pairs that are both unknown. So my final answer is actually C1 factorial into C2 factorial into 2 to the power C, I am saying, where C is number of pairs where both are 0. You can say both are unknown. Okay, that's C. So this formula is going to give me my correct answer for the easier version of the problem. I hope it is clear to you. Okay, so if the logic is clear, we can look at the code now. Yeah, it is a little bit maybe tricky to understand. Like for this was the like main case. If you got y C1 factorial into C2 factorial we are doing, then for every pair where both are unknown, you can have it RL and LR, two ways for every all those cases. So into 2 to the power C you are doing, where C is the number of pairs where both are unknown. If there are no such pairs, then it would C would be 0. If C is 0, 2 to the power 0 is 1 only. So you would get this formula only. Okay. I hope this is clear. We can look at the code of the easier version now. Okay, so I just took the input to n-sized array, and then like CL and CG. So C1 is CL, C left, basically number of elements in the left range from 1 to n. There are n elements initially. CG is in the right range or the greater range. It is lesser range and greater range. That's what I'm denoting with CL, CL. CG, okay, whatever. This is C1 and this is C2 that I explained. Initially, they are n, and C is 0. C is the number of pairs which are both empty. Okay. So these 3 variables we have maintained. Now we need to compute that. How can we do? So we'll go to every pair. So I'm moving from I equal to 0, I less than 2, and I plus equal to 2. So I'm moving in steps of 2. So AI and AI plus 1 are my pairs. Okay, if both are non-zero, then continue. This case would never happen in my easier version. Both would not be non-zero. AI plus 1 would always be 0. Okay, so this was actually written for the harder version. So you can ignore this. This would never happen because the question is given. All the even indexes are always 0. Now, if any one of them is known, or in the easier version, you could have just written AI is unknown. in the easier version, only writing this was in. You can, I think this was also. Okay, so yeah. Okay, so if AI is unknown, so we are moving to all the odd indexes in one based, in zero based, it's even index. Okay, so if that is known, this is not equal to zero. If that is known, then I'm taking the, okay, this is AI only, element is AI only. If that is less than equal to n, then C left minus minus, otherwise C greater minus minus. Basically, I'm checking if that known value falls in my lower range or greater range. If that falls in my lower range, then I would say CL minus minus, otherwise C G minus. So after this, I would compute how many values are left in the lower range, how many values are left in the greater range. And if both of them are unknown, if this is equal to zero, it means both elements are unknown, then my C would be implemented by 1. So there's a pair which is both unknown. So C plus plus. Okay, that way we are computing my CL, CG, and C. So my final answer is factorial of CL into factorial of CG into 2 to the power C. And we have to make everything as mod M. So this fact CL, I'm pre-computing all the factorials mod M initially only. So this factorial array, I am up till 1 is 6, I'm pre-computing all the factorials mod M in my factorial array. Okay, because if I compute the factorial here one by one, it would take O of C time complexity. So I'm pre-computing all the factorials up to 1 is 6. So I'm just using it here. Factorial of CL mod M, factorial of CG mod M. When I'm multiplying 2, again, I'm doing a mod M. Then 2 to the power C, this power M 2C is just binary exponentiation mod M. Okay. This is my binary exponentiation function into 2 to the power C 1. So this way I'm computing my final answer. And this is well accepted. If you look at the time complexity, this input thing is O of 2n, which is same as O of n. And this I'm moving n times. Every time this is O of 1 operation, if else thing is there. So this is also O of n. So basically, and this factorial, they all are pre-computed. This power exponentiation is taking log time. So this is a log n complexity thing. So this pre-computation is taking 1 is 6. So basically, my final time complexity is going to be O of n. So in O of n, and plus for the pre-computation, I am just doing 1 is 6 factorial computation. So that is AI, I can write O of n plus O of AI. Okay. So that's my final time complexity. I hope this easier version is clear to you. So we can move to the harder version now. Okay, if there is any doubt, you can ask. Then we'll move to the harder version. Okay. So let's move to the harder version. Here in the harder version, it said that the extra constraint on the problem that was given here, that all the event indexes are 0, that is not present here. That's the only change. Rest all the constraints and all everything remains the same. Now, what problem would it create? Let's try to think. If I'm telling that there is some where some element, all the event indexes are not 0, it means some elements would be fixed. So it means, let's say here, in this case only, let's say in this test case only, I was along with this 3, I was replacing it with something from the right range, either 6 or 7. Okay. Now, instead of replacing it with something from the right range, if it's already given that instead of this 3, it is written that this is, let's say, 2. Okay. So if both these elements are from the left range, it means the final maximum value that we were trying to get was everything from the right range is positive and left range is negative. This we cannot do now, because if this 3, 2 is given, that means this is fixed, that this 3 would get a plus sign and this 2 would get a minus sign. This is fixed. So if this is happening, then the maximum value that we were expecting, that we cannot get that. Now, after this modification, what is the maximum value that we can get? This we would have to calculate, and likewise then calculate the number of ways to get. Okay, so there is not too much difficult thing to too much change that would occur. What would happen if now we can say that for every pair, okay, now it's a general case. So for every pair, there can be three cases, you can say. Either, okay, so like if this is an array, I'm saying, okay, these are two elements in the array, then two elements, then two elements. So I'm dividing them in the pair. So if you just pick up any pair, either it would be some value, like with x, I'm denoting some value which is non-zero, which is a fixed value, and with zero, it's a non-fixed value. So either it would be x0, or it would be 0x, or it would be both zeros, or it would be both fixed values. These are the only cases that we would have for any pair. So if you just look at the pairs, either both the values are already fixed, okay, you cannot do anything in that, or both the values are non-fixed, you can just give them any value. One of the values or one of the values fixed, you can just take both the cases as together only. Okay, so here in this we have analyzed in my easier version, like this case was not present, these cases were there, like this was also a not zero, so only these two cases were there. Actually, this can be covered in the similar way if this case is also there. So this thing is covered, but when something like this happens, that's what is creating a problem to us. But what is the problem? Like when there was only these three cases, what we were doing is the range that we were defining, like for elements from 1 2 3 4 up to 2n, we were cutting this n between n and n plus 1. That's where we were cutting this. N elements should get negative sign, n elements should get positive sign. Now let's suppose here we are given two elements 1 and 3. Okay, both of them fall in the left range. Okay, 1 and 2. If these elements are already given, it means it gets a plus sign, it gets a minus sign. So what you can do is, these are fixed, you cannot change them. So only look at values where you can change. So ignore both of them. So all those pairs which are XX, all those pairs which are fixed, just ignore them. After that, whatever values you get, where you have the only these pairs, once you ignore all the values, all these values, whatever you get, let's say n was 6 here, you had 1 2 3 4 5 6, you are doing the partition like this. Okay, now if there is a pair of 1 and 2 already present, so this is fixed. So what you can say, you have these four elements left, do a partition here. So for these four elements, divide them into half. So for these lower elements, assign them minus, higher elements assign them plus. That way you would get the maximum value you can, because you obviously cannot do anything with these values, you cannot change them. So what is in your hand is change these values to either plus or minus. So basically what you do for all the, initially only first just check all these cases, remove all those, like you can store all the elements from 1 to 2n in a set, you can store them in a set, erase all those elements, like whenever you get this xx pair, erase those elements from the set. Now whatever you get in your set, okay, whatever things you get in your set, just divide this, the just get the element at the, if the size of the set is, I'm telling as that is the size of the set, then from 0 to size by 2, all these elements are in the lower range, and size by 2 plus 1 up till size, these elements are in the upper range. So just define your range like this. Now just do the same thing as you did in the easier version. Your lower range, to calculate how many values are there in lower range, how many in upper range, would be done through depending on size by 2, not depending on n. That time your partitioning value was n. Okay, Now your partitioning value is size by 2. Just replace n with size by 2, compute this size by 2, replace n with size by 2, and do the same procedure that you did in the easier version. You would get your answer. I hope it is clear, or maybe just try to think yourself one more time. Let's take one test case, and before the harder version. Here both of them are, yeah, it's good. Okay, let's take this test case. Try to understand what we are doing is, okay, first thing, n is 4. So in a set, you just put all elements from 1 to 2n. Okay, put all these elements in a set, then just move these two. Just initially just check for x case where both of the elements are non-zero. Okay, that's the thing that is causing the problem. So here both are not non-zero. 1 0 you got. Here again 1 0 you got. Here again, here you got, both of them are non-zero. So just remove this 6 and 8 from the set. Okay, now here one of them is non-zero. Now what you got in your set is 1 2 3 4 5 7. Now this set is of size 6. Size is 6. So just take this much elements. Okay, up till the first 3 elements. The third element of the set is 3. So just your range is defined here. Okay, so these elements 1 2 3 fall in the lower range, 4 5 7 falls in the upper range. Okay, now just do the thing that you did earlier. Okay, just maybe ignore this and do the thing that you did earlier. Just check first, like C lower, what you were computing, C lower is initially 3, C greater is initially 3. Initialize them by size by 2, not by n. Okay, n was 4, but now 2 elements are removed. You have just 3 elements in each group. So initially there are 3 elements in each group. First, this is 3 and 0. So just remove this 3. Okay, or it falls in the lower range. So reduce this. Now this is 0 and 5. 5 falls in the upper range. Reduce this. This is 0 and 4. 4 falls in the upper range. Okay, reduce this. So basically in the lower range, you have 1 and 2, 2 values. In the upper range, you have 7, 1 value. Okay, so your CL is 2, CG is 1. Now your final answer would be, and your C is 0 here. There are no pairs where both are 0. Okay, if there would be something both 0, you would do C++. Okay, here your C is 0. Your final answer, formula for your final answer would remain the same. Factorial of CL into factorial of CG into 2 to the power C. This would remain your final formula still. Okay. Yeah. Cracking the easier version was the main task here. After that, there was just a small modification that you needed to think about. Okay. I hope it is clear now, so we can look at the code for the harder version. Okay, I took the input. Then what I did, I took a set, inserted all elements from 1 up to 2n into that set, and then I traverse to every odd indexes. So for every pair, I check if both of them are non-zero. I would erase AI and AI plus 1 from the set. That's the thing I did. Now, size denotes the size of my set. Now, in my iterator, I don't need to consider size by 2, but the value at index size by 2. Basically, the value, if my size is 6, I need to consider the third value. Based on that, the partition would be done, not 3. Because if there was removal from the start, if 2 and 3 were removed, I have 1, 4, 5, 6, 7, 8 left. Then my size is 6, size by 2 would be 3. Okay, size by 2 would be 3. But I won't consider 3 as my partition, but I would consider the third value, 5, as my partition. Okay, so my third value is 5. So I would start an iterator from the start of the set, iterate it size by 2 times, I would reach here. Okay, basically the value just above size by 2. So basically I just need to consider if value is less than 6, then it's lower range, greater than equal to 6 is higher range. So my IT start dot begin, size by 2 times, I did IT plus plus. So X is star RT. So X is the thing on the basis of which we are just doing partition. We are going to do the partition. Okay. So if it is less than X, it falls in lower range. Okay. If it is element is less than X, it's lower range, otherwise greater range. Okay. Again, this would remain the same. CL, CG. Here only thing is, if it's this case, we have already considered that here by erasing it. Here we would just use a continue. Now, if AI is non-zero, or okay, here again in the easier version, we just wrote AI not equal to 0. Here it can be AI is 0 and AI plus 1 is non-zero. So both can happen. So if any one of them is non-zero, that means there is one value, 0x case or x0 case. Then my element is max of AI and AI plus 1. So one of them is 0. So max function will return the value which is present, not the 0. Okay, so if that element is less than X, C lower minus minus, otherwise C greater minus. And if both of them are 0, then C plus plus. Okay, final answer is the same. I hope this problem is also clear. Time complexity would also remain the same in this case. Only extra thing is where in this set insertion part, okay, we are inserting into a set that would take n log n time. Okay, so the time complexity would become n log n. So this is going to take n log n time. This is like O of n operation only. So my final time complexity would be O of n log n. And plus the 1 is 6 pre-computation that I'm doing for my factorial. Okay. So I hope this problem is also clear. So this was it for the discussion. Thank you very much.